What's up, everyone? Welcome back. Patrick here, moving on to the next example. So we are given a triangle that has the vertices A, which is at 0 and 6, B, 7 and 5, and C at 3 and -3. And with that triangle, we got to answer these 4 questions here. So we have to find the right bisector or the perpendicular bisector. Both of those mean the same thing, of each side of the triangle. We have to verify, number 2, that there's one point of intersection for all 3 right bisectors. And the point of intersection between all 3 of those in a triangle is actually something called the circumcenter. So that's a term that you may see your teacher mention or you may see come up in your textbook. And then once we have the circumcenter, number 3, we have to find the length from each vertex of the triangle to the circumcenter. And then in number 4, we have to find the equation of the circle through that triangle above. Okay, now before getting into these, I kind of just want to go over just from a high level of what we're going to be doing, just so you understand. So we have this triangle here. Let's just say it looks like this. Okay, it might have a different shape if you were to graph it on a Cartesian plane, but I'm just going to keep the diagram like this for simplicity. So we have this triangle given, and what we're going to do is we're going to find the right bisector of each side. Now, what's a right bisector? Well, if we take the right bisector or the perpendicular bisector of this line here, of this side, well, it's going to be the line that goes through the midpoint. Let's say it's like right here, and then it's perpendicular to the side. So let's say it looks something like that, right? There's an angle of 90 degrees there. And then for this side, let's say the midpoint is like right here. So drawing that like that, that's going to be the right bisector there. And then over here, midpoint is there, right bisector would be something like that. So if we draw actual lines here, what's neat about it is that they're all 3 of them, they're actually going to intersect at the same point. And we're going to show that algebraically. And then this point here, it's actually called the circumcenter of the triangle. Now, we're going to go over a couple of different cases of the circumcenter in a future video, because this is actually only one case. The circumcenter here, in this case, it's actually going to be within the triangle, and if you were to actually plot these points and then the circumcenter, the point that we're going to find, it's actually going to be within the triangle for this particular case. But there's also cases where the circumcenter can be outside of the triangle, and it could also be on the side of a triangle. This point here can be on one of the sides, and we're going to go over those cases in future videos. Basically, it's inside a triangle. This is going to be a spoiler alert. If it's an acute triangle, it's going to be outside of the triangle. If it's a or an obtuse triangle, the triangle contains an obtuse angle, and then it's going to be on one of the sides of the triangle if the triangle is a right triangle, if it contains a 90-degree angle. But again, for simplicity, we'll just deal with this kind of triangle in this particular video where the circumcenter is going to be within the triangle. So we find this point here. Now, what does this point represent? Well, what it represents is actually the center of the circle. If you were to draw the circle that goes through this triangle, and what it means for a circle to go through a triangle, it means that all of the vertices of the triangle are going to be on the circle. Okay, so if we, let me erase this part here. So if we draw a circle, this might not be the best drawing, but let's say something like that, right? So you can draw a circle for any triangle that goes through the triangles as long as the vertices, the 3 vertices of whatever triangle you're drawing, are on the circle. And whatever circle you can draw that goes through whatever triangle you're dealing with, the circumcenter that you found from the triangle is actually going to be the center of the circle that's drawn through that particular triangle. And so what we're going to do then is once we have that circumcenter, we're actually then going to find the, let me erase these so there's not too many lines going on. We're going to find the distance from the circumcenter to each vertice of the triangle. And then we're going to see that the distance from the circumcenter to each vertice of the triangle is actually going to be the same. And that makes sense because if you, as we mentioned, this is the center of the circle. The vertices of the triangle lie on the circle. And if you just have a circle in general and you have the center of the circle, well, the distance to any point from the center to any point on the circle is going to be the radius, right? So it makes sense that all of these distances here should be the same. We're going to verify that. And then once we have the center of the circle, we have the radius, right, which we're going to show in 3 calculations. Well, to get the equation, which is going to be in number 4, we could use that formula that we've gone over in a previous video, where if we have a circle centered at h and k, which is going to be this coordinate, the circumcenter, and then a radius r, this is going to be the equation. So that's how number 4 is going to go down after we have all that information. All right, so just wanted to kind of go over a higher level of what is going on. So when we're doing the actual algebraic steps, you kind of have a way to file it in your mind and it's going to make more sense. So let's start off with finding the 3 right bisectors. So I'm going to actually erase this and then I'm going to draw the triangle again just so we have a fresh diagram. Now this is going to be A, so we'll let this be 0 and 6. This will be B. Again, this is not going to be to scale when you graph this triangle on a Cartesian plane. It's going to look a little different. It's actually going to be rotated to the right a bit. Like this point is going to be down. This point's going to be at 0 and 6. So if we do draw it, it's like 0 and 6. Let's say 3, -3 is going to be here, and then 7 and 5 is going to be like over here. All right, so that's how the actual triangle is going to look. That's going to be A, that's going to be C, that's going to be B. But again, just to not have too much going on here, I'm going to keep the triangle like that. But if your teacher requires you to actually graph what's going on, then that's how it's going to look like. So let's find the right bisector of all of these sides. So first thing we're going to need is the midpoint. So what I'm going to do is I'm actually going to find the midpoint of all the sides first. So let's start with the midpoint of AB. What is the midpoint formula? Well, it's x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So for A and B, we're going to have 7 plus 0 divided by 2, and then we're going to have 5 plus 6 divided by 2. Right? So this would end up being 7 over 2. This would end up being 11 over 2, or 3.5 and 5.5. I'm going to keep it in fractions just in case your teacher wants you to work with fractions, just because it's tougher to work with fractions than decimals. So 7 and 2 there. Now the midpoint between A and C is going to be what? 0 plus 3 divided by 2, right? 0 plus 3, the sum of the x values divided by 2, and then the sum of the y values divided by 2. So we would end up with over here 3 over 2, and then over here 6 plus -3 is like 6 minus 3, which is 3 over 2, like that. So this point here is going to be 3 over 2, 3 over 2, like that. And then finally the midpoint of BC, we would add the x values, 7 plus 3 divided by 2, and then add the y values, 5 plus minus 3, divided by 2, like that. So this would give us what? 10 divided by 2, which is 5, 2 divided by 2, which is 1, like that. Okay, so the midpoint here is going to be 5 and 1, like that. Okay, so we have the midpoint of each side. Now what we need the slope of each side as well, because what we're going to do is we're going to take that slope and then we have to find the perpendicular slope, because remember the right bisector is going to be that right there, right? It's going to be these lines right here. So we need this slope, this slope, this slope. Then we're going to get the negative reciprocals of those slopes to get these slopes of the right bisector lines. So let's start off with finding the slope of AB. Now what is the slope formula? It is y2 minus y1 over x2 minus x1. So let's start off with AB. Now just be careful with your labeling. You can actually use this point and this point, or this point and this point. Because this is a fraction, I'm actually going to use the A and the B, just because there's no fractions there. So I feel like the calculation is going to be quicker. So we're going to have y2 minus y1, which is going to be 5 minus 6, over x2 minus x1, which is going to be 7 minus 0, which would give us negative 1 over 7. Okay, so the slope of this line here is going to be negative 1 over 7, like that. Let me just make sure. I don't want to screw anything up here. Yeah, so we're all good there. So that's the slope of AB. Now, what's the slope of AC going to be? Again, you can use these 2 points, these 2 points. I'm going to use these 2 points. They're all on the same line. The slope of AC, so this is x1, y1. I'm going to let this be x2, y2. So we would have y2, which is negative 3 minus 6 over x2, which is 3 minus x1, which is 0. So this would end up being negative 9 over 3, which would give us negative 3, like that. Okay, so this slope here of AC is going to be negative 3. And then finally, the slope for BC, we let that be x2, y2. Let this be x2, y2. So I'm going to change this to be x1, y1. We could actually use this midpoint too, just because it's a nice integer. But let's just use the endpoints. So we'll have y2, which is 5 minus negative 3, over x2, 7 minus 3. So this would end up being 8 over 4, which would give us 2, like that. Okay, so the slope of BC is actually going to be 2, like that. And then let's say you could check this answer quickly. Like let's say you found the slope between this point and this point. Notice what would you get? You would get 5 minus 1, y2 minus y1, over x2 minus x1. So that would be 4 over 2. You'd get that same slope of 2. So now what we need is, we have the slopes of each of these lines. We need the perpendicular slopes, which is going to be the slopes of the right bisectors. And so it would be the negative reciprocals of all these slopes that we got. So the perpendicular slope, the negative slope over here, or the negative reciprocal slope, or this slope of this line, is going to be this flipped over, which would be 7 over negative 1, but then we're going to change the sign from a negative to a positive. So 7 over 1 is 7. So that right there is this slope over here. I know it doesn't look like it on the diagram. This is a negative slope. This is a positive one. But again, this is just a rough drawing. It's not to scale, but if you were to draw it on a Cartesian plane, then this slope here in the diagram would be positive. right? So that's the slope of this right bisector. Over here, we'll have -3 over 1. So the perpendicular slope there is going to be +1 over 3, right? We change the sign and then we flip it like that. And over here we got 2, which is like over 1. Flip that, it's going to be 1 over 2. And then we change the sign, which is -1 over 2. So that's that slope right there of that right bisector. Okay, so lots written down here, lots going on. You may organize this on your sheet some kind of different way. Maybe you'll just work with each side separately. I kind of just found all the midpoints at once, found all the slopes at once, but whichever way you go about it, just make sure you end up getting the same equations for these right bisectors. So I'm actually here going to erase what we don't need. What we don't need these slopes anymore. So I don't need this, and then I don't need this over here. Right? I'm going to keep the points, the vertice points listed because in number 3 we're going to have to find the distance from the circumcenter we're going to find to each of those points. Okay, so now we just have to find the equations of the right bisectors. So let's start off with the right bisector for AB. Now that right bisector is going to have a slope of 7 and it's going to go through a point 7 over 2, 11 over 2, right? It's going to go through that midpoint over here. So we have to find the equation of a line that has this slope that goes through this point. So y equals 7 over 2x, or sorry, 7x plus b, like that. And then we could plug in for y and x and solve for b. So we'll have 11 over 2, 7 over 2 plus b. This would be 49 over 2. And then bring this over. The b value would end up being 49 or 11 over 2 minus 49 over 2. Right? Which would end up being what? -38 over 2, like that, which would give us -19, like that. Yeah, looks all good to me. So that's the b value. And so the equation of this right bisector is y equals 7x minus 19. So I'm actually going to erase all of this here since we don't need it anymore. And then just put the equation. So that's going to be y equals 7x minus 19. All right, that's the equation of that right bisector. Now let's find the right bisector for, let's go with AC. So that is going to have a slope of 1 over 3, and it's going to go through the point 3 over 2 and 3 over 2. So we would end up with y equals 1 over 3x plus b. By the way, when you're solving for this b value, you might use a different formula. That formula y minus y1 equals mx minus x1. Right, you're plugging in the slope then for y1 and x1, this point here, and then putting everything on one side with the y being on the left side. Just whichever way you're doing it, make sure you're getting the same equation that I'm getting. So we'll have 3 over 2 over here, 1 over 3 times 3 over 2 plus b. Then we'll have what? These cancel out, the 3's cancel out, so we'd have 3 over 2 equals 1 over 2 plus b. And then b would be the 3 over 2 minus the 1 over 2, which would give us 2 over 2, which would give us 1, like that. So the equation ends up being 1 over 3x plus 1, right? Just give me a sec here. Let me make sure that it's all good. Yeah, it looks good to me. So this here is the equation of this right bisector right there. So let me erase all of this. Let me just put the equation. So we'd have y equals 1 over 3x plus 1, like that. That's the equation of that right bisector. And then the final right bisector, that's going to be for BC. The slope is negative 1 over 2, and it's going through that midpoint of the side of 5 and 1. So same process here, y equals negative 1 over 2x plus b. And then we have to plug in 1 for y, 5 for x. This would end up being negative 5 over 2. This would be 1 plus b. Bring the negative 5 over 2 over, so y would equal 1 plus 5 over 2, which would be like 2 over 2 plus 5 over 2, right? To get a common denominator here, which would give us 7 over 2, like that. Okay, so the equation of this right bisector here is going to be y equals negative 1 over 2x plus 7 over 2, like that. All right, so we solved the first question. I feel like that's the question that's going to contain the most algebra, but we got the equations of all three right bisectors. And so now what we have to do is we have to find, or we have to verify that they're going to intersect at one single point. That's circumcenter. That's question number 2. So what I'm actually going to do is rewrite these lines over here, and then I'm going to show you how we can verify that all three lines intersect at one point. I think we actually went over a video in the linear systems unit where we verified the same point of intersection for 3 lines, or I think maybe we were finding a constant to make all 3 lines have the point intersection. But nevertheless, when you have to verify that the point of intersection is the same for all 3 lines, what you could do is you could pick any of the 2 lines, right? 2 of the 3. So let's say we pick these 2, and we find the point of intersection between those using substitution or elimination. So we get that point of intersection, right? From there, what we have to do is we have to just verify that this third line, this remaining line, goes through that point. And how do we verify that? Well, we could just take that point, plug it in for x and y, and just make sure that the left side is equal to the right side on the third line. And if the left side equals the right side for that third line, after we plug in that point of intersection we found from the other 2 lines, then we verify that all 3 go through that point. Okay, another way you could do it is you could find the point of intersection between these 2, and then maybe the point of intersection between these 2, and you're going to get that same point of intersection. That's not the way that I do it. I just pick 2 of the lines, and it doesn't have to necessarily be these 2. It could be these 2, it could be these 2. You're going to get that same point of intersection between 2 of the lines, and then to verify that the third line also goes through that point, plug in the x and y, make sure that the left side is equal to the right side. So that's what I'm going to do. And I'm going to use these lines over here. So I'm going to actually just make them equal, right? The y's are isolated, so I'm going to plug in this expression for this y. So we would have 1 over 3x plus 1 equals 7x minus 19. Different ways to go about it. What I'm going to do is I'm actually going to bring all the x's to one side, all the numbers to the other, so we can bring the negative 19 over. So we'll have 1 plus 19, and over here we'll have 7x minus 1 over 3x, like that. Another thing you could do, because you have a fraction here, you can maybe multiply everything by 3 to get rid of that denominator. So we'll have 1 over 3 times 3, which is 1, so we'll have x plus 3 equals 21x minus 57, right? Then you don't have to deal with fractions. Whichever way you do it, you should get the same x value. And since I wrote it here, let's just do both simultaneously. So this would end up being 20 7 minus 1 over 3. Let's do that on the side. 7 over 1 minus 1 over 3. 3, 3. 21 over 3 minus 1 over 3, which gives us 20 over 3. So this would end up being 20 over 3x, like that. And then to solve this, you could divide both sides by 20 over 3. Another thing you could do is you can combine these to be 1, right? So instead of having like 20 over 3x, I could rewrite this as 20x over 3, and then it's nice because then you could just cross multiply. We'll have 20x equals 60, x equals 3, like that. And then from here, if you did this same thing, bring the negative 57 over, 3 plus 57 would give us 60, bring this over, 20x, same exact thing. The x value ends up being 3. And then to get the corresponding y value, you could plug it in to either of the original equations, the two that you're working with, not to this one, because we picked those two to find the point of intersection for. So let's plug it into this one. There's no fractions here. 7 times 3, 21, minus 19 gives us 2. So the point of intersection is 3 and 2. Then if you want to confirm that here, 1 over 3 times 3, which is 1 plus 1, gives us that y value of 2. And then to verify that this goes through that, it's exactly what I just said with the second line. We just want to plug in for x and y. So we'll have 2 equals negative 1 over 2 times 3. Negative 3 over 2 plus 7 over 2. This would be 4 over 2. Notice 2 is equal to 2. So we verified that this point goes through this line as well, meaning that all 3 lines are going through this point. That's the point of intersection for all 3 lines. Okay, and then if you have more time, if you want to test, like, you can find the point of intersection between those 2 lines. Do the same thing we did before with the substitution. You'll always, no matter which 2 of the 3 you pick, you'll always get that same point of intersection. And that's going to be for any triangle. As long as you get the correct right bisectors, they're all going to intersect at the same point. So if we label this point on the triangle, it's going to be this right there. All right, so we found that's the answer to number 2. That's the circumcenter of the triangle. It's 3 and 2. And let's actually make a new diagram here, just so there's less going on. Let's bring back that circle. So we found, let's say the circumcenter is like over here, right? So this is 3 and 2. I'm not going to draw the right bisectors again, but let's label these points again. So we got 7 and 5, we got 0 and 6, and then we got 3 and negative 3. Now, what we got to do at this point for number 3 is we got to find the distance from the circumcenter, which is 3 and 2, to each of those vertices right there. And as I said, that distance is going to represent the radius of that circle that's drawn. And so all of these distances should be the same if we got the correct circumcenter for that particular triangle. So let's find all these distances. So let's find the distance. First off, what is the distance formula? Square root of the difference between the x values squared plus the difference between the y values squared. So let's start off with 7 and 5, this, and 3 and 2. Okay, so I'm going to let this be, doesn't matter which one you do, I'm going to let this be x2, y2, I'm going to let this be x1, y1. Right, so this would end up being 7 minus 3 plus squared plus 5 minus 2 squared, which would give us what? 4 squared plus 3 squared, which would give us 16 plus 9, 25. Square root of 25 is 5. Okay, so this distance right here ends up being 5, like that. Now let's do it between 3 and 2 and 3 and negative 3. Let's see what we get there. So I'm not going to erase this here, so we would end up with the x2 is 3, right? The y2 is negative 3, like that. So what would we get? We'd get 0 squared, which is 0, plus negative 5 squared, which is 25, and then the square root of 25 gives us 5 again. So as expected, this distance here ends up being 5, and then the distance between those 2 points, so we would have 0 and 6 to 3 and 2, so this is x2, y2, so let's plug this for x2, this for y2. So we'd end up with negative 3 squared plus 4 squared, which would give us 9 plus 16, which would give us the square root of 25, which would give us 5. So, as expected, the distance from the circumcenter to each of the vertices of the triangle is the same. The distance is 5, which makes sense. And what does that distance represent? Well, it represents, remember, the radius of this circle. So if we erase these triangle lines, right, the radius of the circle, which is 5. So now we have a circle that's centered at 3 and 2. That's the center of the circle, and it has a radius of 5. So this is the h, that's the k. What's the general formula? X minus h squared plus y minus k squared equals r squared. So we would end up with x minus 3 squared plus y minus 2 squared equals 5 squared, which is 25. And this is not expanded, usually it's just left in this format. And so that ends up being the answer to number 4. All right, so that's how all of this works when dealing with a circumcenter. That's what it means algebraic or intuitively, graphically. That circumcenter that you found is the center of the circle that's drawn through that triangle that you're given, and then the distance from the circumcenter to the vertices of the triangle or points on that circle represents the radius of that circle. All right, so that's how it all works. So it's pretty neat how it all works, and as I mentioned before, there's different cases for this circumcenter. This is just one kind of drawing that can happen, right? But as I mentioned, it could be outside, sometimes it could be on the triangle, and we're going to go through cases like that in a future video.